Assalamu alaikum, Ahmed. How are you?
Hello, Hasnain. How are you?
I'm good. Good to see you.
Thanks, Hasnain. How are you today? All good?
Yes, yes.
And good morning, everyone. Can you hear me well? Everything is going well? Okay. So just a reminder that our lecture will start on 9:10 every Thursday online. Okay, and the lecture will be recorded and it will be uploaded to the course website. And during the lecture, if you have any question or any query for me, just please stop me and ask. Okay. So let's start just open the slides. Okay. And I will stop the video now, my video. Okay, so let's wait for 2 minutes before until it reached 9:10 to start the lecture. And just before we start, I will introduce myself. My name is Ahmed Shita, and I will be the lecturer and the tutor for the class. So you will see me in the lecture online and in the class. We don't have class this week, but we will start the classes from next week, week 2. And I think I have met some of you before in other subjects. But anyway, my background is structural engineering, and I have also teach courses like design of reinforced concrete structure and steel and timber structures and structural analysis. So my background is mainly in the structure analysis and structural design. Okay, and as you know, Professor Zingama is the course coordinator for this subject or this unit. So we will help you during this semester to get the best like learning experience in steel structures. And the course is mainly divided to two components or like discussing two components. The first part is design of hot rolled structure steel buildings, like using hot rolled sections. And the other half or other part is the cold formed steel structure. Okay. And we have two major assessment, and we have one final exam. Okay. Do you have any query for me about the subject before we start? Kingly T, how are you? Think we met before in steel and timber last semester. Good morning, everyone. So, any query before we start? Nothing? Nothing confusing you before we start? Yes, Kingly. We will have two assessment. The two assessment will be group work. But we will start forming the groups from next week in the class. Okay, so I will quickly share with you the course website. So we have two projects. Both of them are group work. The first one will be steel frame design. In this part, we will use hot rolled structure steel members like, you know, universal beams, welded beams, and so on, broad flange beams. And in project two, which is 30%, so the first one is 20%, second one is 30%. This will be uh, instead of hot rolled, will be cold formed steel. You know, cold formed steel is light structure, so we will learn the differences between hot rolled and cold formed steel structures. Okay. Any other query before we start? Going through the slides. And the final exam is 3 hours final exam, which is 50% of the course. Okay, so let's start our slides today. Again, I will be the lecturer in the online lectures on Thursday 9 to 11, and also you will see me in the tutorial classes from 11 to 12. We have only 1 hour tutorial class starting from week 2. And in lecture 1, we will give you a brief introduction to the steel structures, cold format and hot rolled. And these slides were prepared by Professor Zengma, the course coordinator for this unit. And the requirement for a student in this course, or what you will gain after completing this course, is you will have knowledge about the concepts of hot rolled steel structure and cold formed steel structure. And you have already some knowledge about hot rolled steel structure from the steel and timber course if you have completed this one already. So this is the requirement for you at the end of this course. So now let's start with introduction about the steel as a material and what is the advantages of using steel as construction material. Okay, so as you know, steel is 100% recyclable material. So this is a big advantage for the environment. So this is environmentally friendly construction material which can be reused again in construction. So this gives the steel a big advantage. So we can call steel as a green product. So steel is recyclable versatility. So you can recycle old cars or buildings or bridges or steel cans and so on. This can be easily 100% reused in another application. All new steel is produced with a minimum of 25% scrap steel. So 25% of any new product of steel will contain at least 25% of recyclable steel or scrap steel. So this will help us to be environmentally friendly material and also will not consume more energy to produce the new steel. So this advantage will be helpful in the construction industry because it is energy saving because you don't need to use new energy or more energy to produce new steel, and also you will get rid of the scrap steel, which we have about 18 million ton of scrap steel each year. So it is also interesting to know that 6 old cars can be enough to produce a basic residential dwelling. So 6 cars or the steel in 6 old cars can be reused or recycled to be built as a residential or basic residential dwelling or basic residential house. Okay, so this one interesting fact about the steel as a recyclable material. So 6 cars, like from this photo, scrapped, can be used to build or equivalent to building the frames or the steel frames of a 140 square meter house. Okay, so this is one of the major advantages for steel as a green or recyclable material. So steel, an environmentally responsible material, the average landfill consists of approximately 60% of construction debris, mostly concrete, wood, and plastic. So the landfill contain a lot of construction debris materials, which like form about 60% of the landfill. So it will be better or be good thing to get rid of this scrap as soon as possible. So only less than 6% of the landfill waste is steel, such as staples, nails in wood, and steel rebars inside the concrete chunks. So 60% only of this 60%, 6 of 60 is only for steel. Okay, and this steel, the only material that can be 100% recyclable. Okay, the debris from typical wood-framed home accounts for 1.4 cubic meter of landfill waste compared to only 0.1 cubic meter from steel-framed house. So this means that the construction debris from wood is about 14 times that of steel. Okay, and actually the steel is 100% recyclable. However, the wood is not 100% recyclable. So this gives a big advantage to steel again in environment or regarding the environment effect. So this all advantage of steel from the environmental view. And now we go to the advantage of steel from the performance or structure performance, which will be our focus or our main concern. Okay, so what gives the steel advantages as a construction material? So the advantage of steel, the first one is greater design flexibility. So the steel give you flexibility in design, architecturally and structurally, because the steel can give you the option to use large or have larger spans because the steel is a high strength material. So the advantage of steel is the first one is it can give us larger spans compared to concrete or timber. So this is a big advantage because in some structures like theaters or lecture theaters or warehouses and so on, you will need spans or open areas, large open area. So the steel provides the possibility for larger spans and open spaces without the need for internal columns. Okay, so this one advantage or big advantage of steel. Another advantage of steel is the versatility of the cold formed steel. The cold formed steel, we can give it the abbreviation CFS. So CFS is cold formed steel. As in this structure, it gives you the versatility to build with flexibility in architectural and structural designs. So the steel give you the cold formed steel. This is a cold formed steel structure. The cold formed steel give you more flexibility and versatility in like irregular or uncommon architecture and structure design. Okay, the only issue here in this type of buildings that it need or requires skilled labors. So the advantage of cold formed steel is this can be easily shaped and can give you flexibility in architectural and structural design. But the problem is it needs more skilled labor or more skilled craftsman. So let's summarize or give dot points of the advantage of steel structure as a construction material. So the structure steel as construction material is high strength material, which enables lightweight design. Okay, so high strength means high strength to weight ratio. So the strength is high strength to weight ratio. This means that you can have high capacity or high strength of members with less weight compared to other material like concrete and timber. Okay. The second advantage is low foundation cost because if you have less weight material, so you will have less foundation or less size of foundation. So if you have less size of foundation or footing, so it will be cheaper or low cost. Due to the high strength also, it will enable us to have larger, clear, or open spans. Number four is the prefabrication, reduce construction time and construction financing cost. So as you know, the steel can be manufactured in factories. So this will give us high quality material or like controlled quality material, and also will reduce the time and cost for building or for manufacture. But for example, concrete mainly, you need to maybe mix in the site or mix on site, and also the quality of the concrete will not be that good as steel. Number five is superior seismic performance in earthquakes events. So in earthquake events, the steel has superior seismic performance compared to other material due to the ductility of steel. As you know, steel is more ductile than any other material. So if we have the stress strain curve for steel, so this is a stress strain curve for steel. Or we can call it sigma epsilon curve. So at this point of steel, we have the yielding point, sigma yield, and this point is the sigma or F ultimate. So we have F yield or sigma yield and Fu or sigma U. So at this point, we call it yield point, and here we have the fractional or break point, and this part we call it, this is decline is the post peak behavior. Okay, the ductility of any material is the area below this curve. So when the area under this curve is larger, so this means that we have high ductility of the material. Okay, so this means the steel under stress will elongate. So all this is strain will elongate enough before fracture or before failure. So up to here, the steel doesn't break. So it will only start breaking gradually from this point. And the final failure will be here. If you have seen any like dog bone test of steel. So when you apply tension force on this steel, the steel will not break suddenly. So this is what gives the steel big advantage in earthquake design compared to timber and compared to concrete. The last one or the last advantage is complete recyclability and environmentally friendly material. This one we have discussed earlier in this slide or before this slide. Okay, do you have any question or any comment up to now, guys? Brendan and Ahmed. Ahmed, you have joined later. Do you have any query, guys? Any of you?
Yes, I am good.
All good? Shahid? All good, Shahid? Okay, thanks for confirming, guys. I just try to be more interactive during the lecture slide. So this is generally the most advantage or the most common advantage of steel structure compared to other structure. Okay, and one example of the clearer or larger span, for example, if you have a warehouse, you need to design if the span, for example, is 40 meter. So if the span is 40 meter, the most appropriate system for this span will be steel frame. So this will be the most appropriate system or the most cost effective system. For example, you will have frame each whatever the distance is, for example, 6 meter or 5 meter and so on. So this means that the steel provide us a clear span of up to 40 meter without the need of any internal column, for example, here. So no internal columns. So this is a big advantage in design or construction industry because in some cases you the purpose of the building will require to have clear spans. So the steel will give us this advantage. And now we are starting explaining or discussing the differences between the two type of steel available in the market. The two different type is because of the way of or the method of manufacturing of both sections or both type of sections. The first one is the hot rolled steel section, like I-beam or universal beam section, or broad flange beam, or sorry, broad flange channel, and so on. So these are hot rolled, cold formed steel. They are thin walled. So thin walled steel. This one is thick or thick walled steel. So the main difference is the way of manufacturing both sections, and the way of manufacturing both sections affect the thickness of the sections. So the cold formed steel are very thin members, ranging between the thickness ranging between 1.2 to 3 millimeter. Okay, can be C section like this or Z section like this. So can be C section and Z section. Okay, so these are the two common sections we have, and we have two videos to watch to see how the steel, hot rolled and cold formed steel are manufactured. So let's open the first video quickly here.
Steel is highly resistant to shaping when it's cold, and for that reason, it is generally rolled whilst it's hot. To make sure the steel is at the correct temperature for rolling, it is fed into a furnace. Here it travels through several temperature control zones until it's at the correct temperature and ready for rolling. Whatever the product, the principles of hot rolling are the same. Steel is squeezed between rolls until the final thickness and shape are achieved. To do this, the rolls must exert forces of tens of millions of newtons, equivalent to a weight of thousands of tons. The rolls, therefore, run in massive bearings, mounted in housings of enormous strength and driven by powerful electric motors. These are known as mill stands. The layout of a rolling mill can vary from a simple single-stand mill to several stands positioned either side by side or in a line. The mill rolls themselves can either be plain for flat products such as strip, used for products such as cladding, or profiled for sections, beams and columns for use in construction. Mill stands have various roll arrangements depending on the product being rolled. The simplest arrangement is a two-high stand, used mainly for long products such as sections. For light sections and bars, three-high stands are sometimes used, with the steel passing one way through the bottom gap and back through the top gap. Four-high stands have two work rolls in contact with the steel, supported by larger backup rolls to prevent distortion caused by the rolling face. These give greater accuracy for rolling flat products, such as plate. Universal beam mills include stands with both horizontal and vertical rolls bearing on the steel simultaneously. Rolling processes are computer controlled and monitored up to 50 times per second. Despite the huge scale of some mills, accuracy to plus or minus 50 microns can be measured. The rolled steel is then cooled in a way appropriate to its end use and prepared for further processing or dispatch.
These forges are absolutely massive.
Okay, guys. Was the video voice clear or not? Okay, clear? Okay, thank you. Okay, so this was a hot rolled steel section manufacturing. So the idea in hot rolled, from the name, it is the steel need to be under under high temperature so that it lose its strength, so that we can be able to like form it or roll it. Okay, so it is very hard to make or bend the steel when it is in the ambient or the normal temperature, because the steel is high strength material. That's why it need to be like under high temperature, for example, as the video mentioned, 700 or 800 or so that we can be able to like shape or make or produce our shapes using the rolls. Okay, so this is hot rolled, and now we will see the cold formed so that we see what is the differences or what is the major differences between both. Let's open this one. So the video I will open or I will start now is for the cold formed steel.
This is a Dalarna University production.
Roll forming is a process where a metal sheet passes through a series of roll stands that change the sheet's shape. The sheet undergoes what is called a profile bending. Roll form details are very common in, for instance, the furniture, construction, and car industry. It is possible to create advanced profile shapes in high-strength materials, and many different materials can be used. All materials that can be bent can also be roll formed. Roll forming is gentle on the material and has a minimum of wear on tools. Today, the roll forming process and the tools are designed in a computer environment before production. Computer simulation is an important tool in order to analyze the roll forming process. Geometry, forming forces, and residual stress are factors that can be monitored in the material. The roll stands are designed so as to allow the material to undergo a gradual shape alteration. Here, the different steps are illustrated in a so-called flower pattern. This is a roll forming machine with 6 roll stands. It does not have an automatic feeder, instead it is fed manually. More advanced profiles require more roll stands in order to reach a final result. This machine shapes the strip into a simple V profile. Note that the sheet springs back. Spring back is the elastic deformation that appears after shaping. Spring back is compensated for when the roll stands are constructed, thus overbending the sheet and letting it spring back into the correct form. What the roll forming tool looks like is decided by what kind of profile is needed. The starting point is to draw a cross-section where the required radii, thickness and dimensions are applied. The minimum radius for bending is decided by the thickness and the properties of the material. Here, it is also decided if the profile will be punched or pre-cut, and if it needs to pass through more preparatory stages before roll forming. There is a great demand for machines that can complete as many stages as possible in a single production line. If more operations can be incorporated into the production line, large volume processing will be more cost-effective. Roll forming can be a part of a production line producing profiles that do not require further refinement, but are ready to be used immediately.
Okay, guys, let's return to our lecture. So the main difference, as you can see, for the cold formed steel, it is rolled in the normal temperature without applying any high temperature to the steel, and that's why we need very thin section or plates to be bent to form the cold formed steel section. So it is different techniques for manufacturing of both steels, but both of them has different applications. That's why we need both of them. Okay. So here we have very thin sections. Maximum is, for example, 3 millimeter. But here it can reach up to 24 or maybe 30 millimeter in some cases. Okay. So from this, you will know that this is heavy, a little bit heavy because you have more materials, but the cold formed steel are light section or light structure. Okay. Do you have any question about the manufacturing process of steel? Oh, good. Okay. So let's jump to the next slide. What is the application for the hot rolled steel? So hot rolled steel will be needed when we need or we have structure that carry heavy loading. So if you have a structure that will be carrying more loading, like more life load or more wind load or so on, so you will need strong or heavier structure to carry this loads. Also in long span structure, because the problem in cold formed steel sections, it is thin material. So if it is thin, what you have if you have a member or column under compression? What do you think? Do you expect what will happen if you have a member or element under compression? It will be susceptible to buckling. So buckling is our problem with cold formed steel because it is thin. So it is susceptible or subject to buckling more than the hot rolled steel. So in long spans, we will need thicker material or we will need to avoid the buckling. So that's why we will need the hot rolled. In high rising building, also we have high rise building, so many stories, so many or more loads. So we need more loads and more wind and earthquake loads as well. So more vertical loads and more lateral loads. So we need hot rolled steel sections. In especially shaped structure, we will need also hot rolled steel. For seismic or high seismic areas, we need seismic resistant structures. We will need hot rolled sections. So these are some common application or some common buildings or structures that require hot rolled steel. So let's have a look on the available hot rolled steel section in the market. So hot rolled steel, we have plate and we have UB section, UB universal beam, and UC universal column. And we have welded beam and welded column. So welded beam, we have, as you can see, we have top flange and bottom flange, and we have a web similar to the other, but the difference is we have welded the web to the two flange. That's why it is called welded beam. For the welded column, same. So we have top flange, bottom flange, and this is welded to the web. Okay, but universal beam and universal column, it is hot rolled or hot rolled in the factory or manufactured as one element. Okay, if I ask you what is the difference in the shape or what is the differences between UB and UC section? So UB and UC section, what do you think is the difference? Can you see difference in the shape? Both of them are I or inverted H, but the idea is UB is universal beam, so it is mainly used as, I just have a answer here. Yeah, the flange width. Thank you, Brendan. So the flange width here for UB is small compared to what? The web. So we have narrow flange width, but here we have wide flange width. This is because of the use of each of the sections. So universal beam is mainly, or the most appropriate use is beams. So in beams, what you have on beams, you have bending moment. So what you need to resist moments? You need, if this x-axis, so you need strong I x, for example. Compared to what? Compared to IY. So for beams, we need inertia, more inertia around x-axis because we will have moment about x, mx. So mx will be resisted by ix. But for universal column, it is mainly used for columns. For columns, the column may buckle in two directions, one in this direction or one in the other direction. So this and this, what we call this LBX and LBY. So for columns, you need IX and IY are close or comparable. So not big difference between them. That's why we need IX is close to IY. That's why they make the flange wider in the universal column sections. Okay, so this is the logic behind the shape of the hot rolled universal and universal beam and universal column. Okay, another type of I section or hot rolled I section is the taper flange beam. The taper flange beam, as you can see, we have the flange is not with a constant thickness. That's why it is tapered flange. So this also one of the forms of the I-beam. Okay. We have also hot rolled channel and angled underbar. So we have the BVC or parallel flange channel, and we have equal angle channel, and we have unequal angle channel. Sorry, equal angle, sorry, and unequal angle. So this leg is equal to this leg. Here we have different angles, different leg for the angle. We have also flat bar. We have also square section, square solid section, and we have also rounded solid section or rounded bar. So all these are bar sections for the hot rolled steel. Okay, so this is these are the common cross section available in the market for hot rolled. And here are some application of the hot rolled steel. As you can see, we have columns, we have girders or beams, and we have purlins or secondary beams. So this is a single story building, for example, workshop or warehouse. Another application of hot rolled is multi-story building. So the main frame of the building will be from hot rolled, like we have columns, we have again beams, and we might have bracing somewhere. So we can have also bracing. Another application is long span truss structure. Like on the top here, can you see truss structure? So for example, in some spans, like if we open a new slide here. So for example, if you have very large span and you want to cover it without any internal column, you may need to cover this with a truss. The system, instead of a solid frame, can be a truss. If I ask you what is the advantage of using truss frame or trussed frame instead of a normal frame? Yeah, lower weight, because what will resist our bending and our deformation? The depth. So we need larger depth of the element. So if you make this frame as a solid I-beam or solid U-beam, the first thing is it will be very heavy and also costly. So what we will do is, instead of using it as solid, we make it as hollow section. So this hollow truss, I mean, you just remove some of the material, but still have the same strength of the element. So this will give you lighter option. Okay. So this is an example of that, because you are building aeroplanes or airplanes. So you need, the airplanes are very long, so you will need very open and longer span structure. So you may need to use trusses. Another application is long span bridge, like this one here, arch structure. So as you know, also we can benefit from the arch shape. And if the span is too big, you can make arch or steel arch, structure steel arch. More application like the World Trade Center in tall buildings. So the problem in tall buildings is that we have issue with the earthquake and wind loads. This is the critical design consideration, is earthquake and wind load, because this is a very high or a very tall building. So if you have any earthquake or any wind, the building will vibrate too much, so you need strong or high strength elements to resist this vibration and this draft. So you will need hot rolled steel structure. And actually, the hot rolled or the high rise building or the tall building is composite structure. Composite structure means you will use hot rolled section along with reinforced concrete as well. So not only steel, because as you know, the slabs or the floors need to be from concrete. Another application or one more application is tower structure or electricity power towers. Okay, so as you know, the high voltage electricity lines need to be carried using high-rise towers. These high-rise towers are from hot rolled sections. Because again, the main problem in this one is the wind load. So this structure doesn't carry any or almost very minimum vertical load, but it carry wind or lateral load. That's why we need hot rolled steel structure to support or to carry this power lines. And this is another one, maybe like antenna for mobile network or something. So all these high towers will need to be built using steel. And lastly, special shaped structure like statues. Like if you want to make a architectural design of a statues or something, you may need to use hot rolled special shaped sections. Like in this two photos. So all these are possible application for structure steel, hot rolled steel sections. And the last point, or one of the important point in the steel, is how to connect the steel members together. So we have the connection details or the connection types. In steel, in hot rolled steel, we have two type of connection. What you can see, what is the first one and what is the second one? We can connect the steel with welded connections. So in this one here, we have welded connection. And in the welded connection, we have two. We have butt weld. What is the other type of weld? Do you remember? And fillet weld. The other type of connection is using bolts. So we have bolted connections. Okay, so these are the two common connection types in hot rolled steel. And now we go to the application of cold formed steel. So the main application of cold formed steel or the advantage of cold formed steel over the hot rolled steel is light weight. So when you want to have lightweight structure, and well, this will lead to lower cost, you will need to use cold formed steel or CFS structures. Why lightweight? Because it is thin walled material. So if it is thin, so it will not weight or not weight, the weight of this material will be less than the hot rolled ones. And here are some common shapes of cold format. These are the C sections. These are Z section, or Z, sorry. And what is the difference between the first one and the third one? Do you know? Do you have a comment on that? This also C section. The difference is this part here. There is no part here. So this called libbed C section, and this one is unlibbed C section. Okay, and we have number 4 and 5 and 6. This one is hat section, and this one libbed hat, and this one is like angle. So all these are common shapes of cold formed steel, but the most used one are C and Z section. And the main or the most common use is in purlins. So in purlins, usually they use cold formed steel purlins because it is lightweight and it will give you lower cost for the purlins. Okay. Any question up to now, guys? No question? Do you want to have rest for 5 minutes?
Can
Or
we have
continue?
it, please, sir?
Sorry?
Can we have 5 minutes break, please?
Yeah, I'm asking. I will see you at 10:10. Is that okay?
Yep, thank you.
Thank you. Okay, so we come back to the common cross section. So the common cross section for cold format steel, as we mentioned, are C section, libbed C section, unlibbed C section, and Z sections, and head section, libbed head section, and angles. Thank you, Ahmed. And now we go to other common panel cross sections, like for example, roof sheeting. So the roof sheetings are made of cold format steel, CFS. So some roof decks, like this one here, the corrugated sheet, or long span roof decks, can be other shape like this. So if you need to select a roof sheeting, you can refer to the brochure or the tables of the manufacturers like Lysat or other manufacturers. So a lot of profiles are available in the market. In cellular floor panels, we can use this profile or this profile. So curtain wall panel can be this profile, ribbed panel, this corrugated sheet as well, and the normal corrugated sheet like this one. So all these shapes are common shapes for roof sheeting and walling, and can be available in the market. Like for example, Lysat. Okay, and this is some details of the cold formed C-shaped section. This C shape is consisting of web, flange, and can be with lip or without lip. So this part is lip. So we have lip, flange, and web, and this is the thickness of the sheeting. Oh, sorry, of the channel, or in cold formed steel we call it C section. So this thickness is limited to 3 or 3.2 millimeter. So you can't have very thick section of cold formed steel due to the manufacturing process of this section. Okay. So the Berlin can be from C section as we mentioned earlier. Also the stud will be using the same shape. The difference is stud is a vertical member and Berlin is a horizontal member. So the Berlin or the joist are like beams. Stud is a column. So the stud carry axial load, or it can be vertical also or horizontal, but usually vertical. So similar to another option of stud, if you have a plan. So if you have bracing, for example, so we can call this part as a stud. So stud can be vertical member usually, but it can also be horizontal. And in horizontal, usually when it is carrying compression force. Okay, so the main characteristic of the stud, it carry axial load, but the bevel and joist are horizontal member, so it mainly carry bending moment and shear force. So this is the difference between joist and stud, but both of them will be C-shape section. The thickness between 0.75 to 2 millimeter, and it have a galvanized coating. So as you can see in this image here, the cold formed steel are secured or are having a protective coating, which is galvanized coating. This galvanized coating is very thin, it is like 0.2 millimeter or sometimes 0.1 millimeter, so based on the cross section. We have also some non-structural studs, which is not designed to carry loads, so it is just maybe there for architectural purpose, or for example to support window or something, or door. So the thickness is less than 0.9 millimeter and also has a galvanized coating. We have also the joist or the purlins. So again, the joist and the purlins are from C section or Z section. Same element like studs, but they are carrying bending moment and shear force. The whips are typically between 200 and 14 millimeters. So the depth of this section, which is D, equal to 200 to 14 millimeter. So it's still, it is still C-section, but different use. Cold roll channel. The channel is same shape as C, but it is a little bit smaller. So cold roll channel. This cold rolled channel is used for wall bridging and fits through web bunch outs in stud and joists. So the C channel is just used to bridging. So if this our, as we mentioned, our studs, so the small channels are wall bridging. Okay, so it is just giving like lateral support to the studs or to the purlins. So this also one shape, one cross-section shape of the cold formed sections. Another shape or another element is straps or bracing members. So as you can see, for example, if you have this element here, so this diagonal bracing are used to resist lateral loads. So it can be also from cold formed steel straps. Or here we have two studs, for example, this a stud and this a stud. So you can do the bridge or the lateral support using, it's still strap, but it will do the same rule as this element here. So it is connecting two studs together, but diagonally instead of horizontally. Okay, another element like straps is bracing, so it's same item or same member. So if you need to resist the lateral load, so you can add the straps or the bracing. The straps usually diagonals, and here is horizontal bracing. So these are also from cold formed steel. It can be from cold formed steel sheets. So it doesn't have shape, just a sheet. So it is like plate, but it is a thin plate. Yes, the meeting is recorded. Okay, so now we jump to the next slide, which is no worries, which is common uses of the cold formed steel stud as framing member. So the cold formed steel stud usually are used in residential buildings, and some of the common use are residential. So because it is low cost accommodation and can be used in single and multi-story. So similar to the previous images here, as you can see, this is studs. Or in this image as well, here is some studs. So the studs can be used in residential building because it provide low cost accommodation, like cheaper option for building, and also can provide, or we can use it in single and multi-story buildings. Also, the studs can be used as non-load bearing walls or curtain walls. So this both are non-structural application of the stud, as we mentioned earlier, because it doesn't have much loads Also, it can be used in light commercial and institutional buildings. So the studs can be used in light structures, commercial or institutional. Also can be used in mid-rise buildings and can be used as joists as and trusses. So all these are common uses of the cold formed steel studs, and these are some examples here for cold formed steel studs and other elements. So as you can see here, we have the bracing, we have studs, and we have truss, we have the roof sheeting, and we have the trusses in the other direction as well. So all these are cold formed steel members that will provide low cost accommodation for single story or multiple or two stories like this one. So these two are two examples of low cost accommodation. Another is mid cost residential, like if you have like this prestigious house, so it can be used also from cold formed steel section because it is lighter option and also lower cost. Okay, so these are example of the residential low cost and or like uh, cheaper accommodation and mid cost accommodation. And this may be another house like higher cost because it is bigger house, but still using this cold formed steel studs and joists and trusses. Okay, so all those are examples of the residential buildings using cold formed steel. In this one, we have commercial and industrial building, like for example, workshop, like two-story workshop or warehouse. So it is from also cold formed steel, like we have cold formed steel truss, and we have studs, and we have bracings. Okay, so this is another example. Another example of commercial and industrial building as well. So this is also a warehouse, for example. But here, what you notice here, what do you have any note here for this building or this structure? Do you have any notice here? Yeah, it is the floor. Yeah, the floor may be composite. The floor, this one note, good note. The floor may be, or it is actually from composite structure. So it is reinforced concrete with steel sheeting. Is one note. Another note is what is the columns and beams? Are they hot rolled or cold formed? Yeah. So for the main structure element like column and beams, it is from hot rolled sections. Okay, so we can also have a mix between the structure section, cross section, like beams and columns from hot rolled, or the main structure elements from hot rolled, and other elements can be from cold formed steel. Okay, here as well, we have the roof is from cold formed steel trusses. Okay, another examples here is commercial mixed use. So these are all structures are from cold formed steel, can be used for residential and commercial. So for example, like shopping center, and we have other story for example accommodation or a hotel or something like this. So that can be commercial mixed use structure that can be also made from light cold formed steel structures or section, sorry. And also institutional, so in the institutional buildings like universities or college or schools and so on. So this can be also from cold formed steel, like this roof here. And as you noticed in the previous slide, it can be a mix between cold formed steel and hot rolled steel, and also reinforced concrete structure. So you can use different material in the same building. Doesn't all need to be from same material. As you can see, what is this? Is this and the slab? Can you see the slab? Is the slab from steel or from concrete? What do you think? It's from concrete. Okay. The color may be inside, we can see it clearly, but we have some studs here. So the studs are from cold formed steel. So you can use a mix of the material in your design. The cold formed steel also can be used in mid-right structural buildings, like this one here. So as you can see, the slab or the roof from cold formed steel joist. Okay, and also here, if you can see, the studs also are from cold formed steel. So all these examples of application will give you an idea about the importance of cold formed steel as the hot rolled steel. So in this too, we have multi-story buildings. In this multi-story buildings, we have also again a mix between, we have composite slabs. The composite slabs, just for your information, is, as you can see, we have a roof sheeting, for example, and then they fill this with reinforced concrete. So it is a mix between roof sheeting, which is cold formed steel, and reinforced concrete slab. And also we have the studs, and the studs are from cold formed steel. Similarly, here we have cold formed steel studs and composite slabs. Non-load bearing exterior studs, like for example, this studs here on the exterior, so it is just to carry the curtain walls, for example, or just for decoration. So in some cases, we have like cold formed steel non-structural studs, which is not designed to carry load, but just there to support or for architectural or decoration purposes. And the joists, some joists like this one here, this cold formed steel truss joists. So the joists are similar to Berlin, but maybe in the truss form, as you can see. So it depends on the span of the joist. So in some cases it can be normal like C section or Z section, or sometimes if it is larger spans, it can be from steel. So it can be from trusses like this one. And here is the main truss or the main supporting element. So the main supporting truss is also from cold formed steel, as you can see here or here in this roof or in this roof of the warehouse. So all these are applications of the cold formed steel sections. Another one here about the portal cabins. So in some cases, if you are working off sites, so you will need to have accommodation, and this accommodation will be built, for example, from the cold formed steel sections, because the cold formed section will provide a light option or light solution for that. So it will be easy to move and easy to build. And as you can see here before, it is covered by walling or before completing the walling. So it is from cold formed steel, and it is also covered with sheeting or walling sheets to provide the side walls of this cabin. So the portal cabin is need to be lightweight, so it is a lightweight structure, and also should be cheap option, and also will be easy to transport. Okay, because this is designed to be a temporary accommodation, so it need to be moved from a place to place. And similarly is the labor camps. So the labor camps also is a temporary, but maybe for longer term. So you can build labor camps in the construction site or the off-site. Sorry, or the like mine or something. So it can be from cold formed steel because it is single or like mid-rise story building. So it can be from cold formed steel structures. Also shed, like the domestic shed for your backyard or for storage. So the domestic shed can be from the lightweight cold formed steel studs, and also it will be covered with roof sheeting. So if we can see this image here. So the walling and the roofing also from roof sheeting and walling or wall sheeting. So this is examples of sheds. And as we mentioned also, again, the deck or the slab is from composite reinforced concrete and cold formed steel slabs. Okay, so again, if we draw it clearly somewhere here, So if this your roof sheeting, for example, so this is they used it as a like roof sheeting, but it actually it works as a permanent formwork for the slab, for the RC slab. So instead of using timber formwork, they use this as a formwork. Then they pour the concrete on top here, and before that they need to embed the reinforcement. So this is our reinforcement bars, and here we have the concrete. So this is a cross section of a composite slab that can be used in composite structure like this one. Now, after we have seen some examples or many examples of the cold formed steel, so we now need to know what is the possible or what is the available connections in cold formed steel structure. So in cold formed steel structure, because it is thin cross section, so screws can be used in the cold formed steel structure. So screws are the most common fasteners used in cold formed steel framing connection instead of bolts, because in the hot rolled we can't use screws because screws are too weak for the thick section. So in cold formed we can use the screws. Alternative fastening methods includes welding, pneumatically driven bends, powder acquainted fasteners, clenches, rivets, and other options. But the most common one is screws. So let's have a look on some of these other options, which is welds. And for the screws, if you have these two sheets, so you will have one screw here. So this is screw, the first option. Another option is welding. So welding can be also used for cold formed steel. It can be fillet welding or spot welding. So if you are connecting these two plates together, you can weld the two plate with the fillet welding here between the two plates. So this one and this one. So you can have a fillet welding here between them. Another option is in plan. So you are connecting these two together. So you create a welding point between the two. Okay, so it can be spot welds or fillet welds. In hot rolled, it is fillet welds and butt welds. As we mentioned, the most common one is the screws and nails. The screws and nails. So you have this one and this one, similar to this GIF here. So you are putting the screws or the nail between the two. So the screws or nails can have different types and different lengths, as you can see. So this is common because of the thin walled nature of the cold formed steel, and it cannot be applied in hot rolled steel. So clinches as well is one of the connection type between cold formed steel. It is like making a connection without a bolt. So using this tool here, so they are clinching the two blades or the two elements together using this material. Okay, because the easy to clinch together, that's why the clinch is option in the cold formed steel sections. Okay. Do you have any question about the connection types of the cold formed steel? No? So now we jump to what is the issue, what is the important issues to be considered for steel structures subjected to different loading. So what is the issues or what is the problems we need to consider when designing steel structure? Cold formed steel or hot rolled steel? These general ones. So apart from the general strength and serviceability requirement, because as you know, the design is two criteria, so strength and serviceability. So these are the normal procedure of design. So for example, if you are designing for moment, so the applied moment on the structure or the element need to be less than the strength of the member, for example. And for the deflection, delta of the beam should be less than or equal to the allowable limit, for example, L over 300. So these two are the basic design considerations that we need to take into account. Additionally, we need to consider tension or fatigue and cracking. So for example, if you are applying load continuously or repeatedly in repeated load, the repeated loads caused fatigue in steel. So even if the load is not causing failure directly, but applying the load repeatedly will cause something called fatigue. This fatigue will cause cracking or fracturing of the steel, which means failure. In compression, we need to consider the main problem, local and global buckling behavior of steel. So the buckling is the most important problem we need to consider in compression. Also in bending moment, we need to consider the local and the global buckling. So local and the global buckling actually is the most critical issue we need to consider in our design because the steel materials are thin or relatively thin, so it is susceptible to buckling easily. Again, in bending moment for dynamic loading due to repeated load, we are aware of or we are worried about fatigue. We should be aware of fatigue. Okay, so these all are just like some hints about the consideration we need to take during our design. So one of the common issues is the local buckling of thin plate elements. So we have different type of buckling or different forms of buckling. So again, the buckling is associated with what? Compression stresses or compression. So any element or any part of the member under compression will be under buckling. But we have two type of buckling, local and global. We have local buckling. So for example here, the original shape of the structure still same. So if the original shape still the same or the member still keeping its original shape, so this is not a global buckling, but it is a local buckling. So in this spot and this spot, the flange or the compression flange buckled. So this is considered a local buckling. Here we have also buckling, but in the web, because the position of the member has been changed. So if this is the location of the member, so the buckling happen in this spot and this spot. So this is called local buckling problem in this member. So this in beams. In columns also we can have buckling or local buckling due to the compression. So for example here, when we apply the load from top and from the bottom, so the flange has buckled. Here, because it is hollow section, so the the sides of the column has been buckled. So all this slide are local buckling issues because the original shape, it doesn't change. So or the orientation of the member doesn't change after the buckling. But here, let's see the global buckling behavior. One of the global buckling behavior is the lateral torsional buckling of the beam. So the lateral torsional buckling of the beam happened due to weak torsional stiffness of the open section. So the open section, like I beam or C section, is susceptible to lateral torsional buckling due to weak torsional stiffness. So this is due to the nature of the open section. So for example, this was our original beam. But the beam has been, like, as you can see, like if this is the original beam, so the whole beam has side or lateral torsional buckling in this direction. So if this is the original beam, so this is the lateral torsional buckling. So the whole beam has buckled, not only one point. So I will just draw it again. So for example, if this is a beam, let's just try to make it clear. So if this the original position of the beam, so due to lateral buckling, the beam has moved in this direction like that. So this is the original location and this is the location after, or the orientation after the lateral torsion buckling occurred. So if we make a cut here, so this is the original and this is after buckling if we cut here at mid-span. So the original position of the rafter or the beam has moved laterally in this direction due to the lateral buckling. Okay. Another example of buckling is this column. So this column under compression, and we have different mode of buckling. Can you mention what of them are local buckling and what of them are global buckling? Do you know? So the first two are local buckling. Yeah, thanks Abu Saleh. And the second two are global buckling. Okay, so this is what is meant by global buckling. This is the original column, and at some stage, this becomes the column new position. So we have the whole column has buckled in this two, but in this one, the column still as it is, the shape as it is, but at some spots of the column, we have some local buckling. So this is the buckling differences. So local is at some or few spots. Global is the whole column or the whole beam has a buckle or change its orientation or its position. So this is a summary of the differences between the cold formed and hot rolled steel members. The first one is the material property. So the hot rolled steel is soft when manufactured at temperature of 700 or 800 Celsius. So we need to apply high temperature on the steel to be able to roll it. So steel in this case will be low residual stresses and high ductility. For the cold formed steel, it is plastic deformed when manufactured at normal or ambient temperature or room temperature. So in this case, the steel will be with large residual stresses and low ductility due to the cold hardening. So the another difference or another effect of the manufacturing process is the ductility. So cold formed steel is less ductile compared to hot rolled. This doesn't mean it is not ductile, but it is less ductile or has less ductility compared to the hot rolled steel. The second one is the geometry. Hot rolled steel with plain elements, plain plate elements, and also thick section or thick elements. For cold formed steel, much thinner profile and easy to shape. Okay. So the cold formed steel much thinner, and because it is much thinner, maximum of 3 millimeter or 3.2, so it is much easier to shape. For structure number 3, another difference, each one of them has different Australian standards. So hot rolled steel is designed by AS 4100. Cold formed steel is designed using AS 4600. Because the design consideration for each of them is different due to the thick and the natural, thick and thin natural of both of them, so they are not following same standards. But generally same concepts, but a little bit different parameters and different formulas due to the thin and thick shape of both of them. So these are the weekly content. For the hot rolled steel, we will work on this from week 1 to week 6. So week 1, we already have gone through the introduction. Week 2 and 3 are the axially loaded members, columns, and struts. Week 4 and 5, flexure design and combined loads for beams and joists and so on. Week 6 is the steel frame design. And this will be covered by assessment 1, which is 20% of the course. For the cold formed steel part, which will be second half of the course, from week 7 to week 11, and week 12 will be revision for the whole course. So week 7 we will discuss the structural behavior of thin walled. We will consider the local buckling and the global buckling and torsion behavior of the members. Week 8 we have the effective section and effective width, which is the design procedure of the cold formed steel for axial loaded member. In week 9 we will have guest lecture and introduction to assignment 2. Week 10 we will have flexural member design. Week 11 we will have column design or axially loaded member. Okay, so these are the weekly content of the course. And the assessment, as I mentioned, assessment 1 for hot rolled steel, 20%, due in week 9. We will form group of 3 maximum. And assignment 2 for cold formed steel, 30%, again, group of 3 students maximum. Usually it will be same group of assignment 1, which is due in week 13. The final exam, which is 50% of the course, it will be 3 hours exam, open book exam using the Australian standard AS 4100 and AS 4600. You should have a copy from the two standard as soon as you can. The requirement of passing this course, as you know, there's two requirements. One exam hurdle, so you need to get more than or equal to 40% of the final exam. This number 1. Number 2 is the general requirement to get 50% of the whole grade of the course. So we have two requirement to pass, 40% in final exam and 50% in total. Okay, do you have any question for me, guys, about that? Or any clarification is needed? Yeah, this week. Just to make some update on it, and it will be released by tomorrow or weekend maximum. But it is already ready, I think, but just making some updates to it. And we will start forming the group from next week class. So please, all of you try to attend the class so that we can form the group. Otherwise, if you missed forming the group, it will be maybe hard to find a group. So the best way to come the first class to join the groups and finalize the group from next week, week 2. And I will explain the assessment or introduce assessment 1 in the lecture next week or in the class, one of them. The textbooks or references for this course are Australian Standard 4100, Australian Standard 4600, and the Steel Designer Handbook. This for hot rolled steel. And cold formed steel design for the cold formed steel part. Okay, we will also need to use the capacity tables for cold formed and hot rolled steel. As you know, we are designing the steel material, like steel cross section, so we need to have the probabilities and the dimension and weight of the section. That's why we will need the capacity tables for hot rolled and cold formed steel, which are available on the course website already. Okay. And this acknowledgement is for some slides are from the guest lecture of University UOA. The course is CIV 711, Introduction to Light Steel Framing by Mr. Nader El Haj. Okay. And thank you for attending the lecture today. Do you have any query for me before finalizing the lecture? Thank you, Hasnain. Thanks everyone for attending today. And if you have any query, you can send me email. And I will see you next week. Thank you, everyone.